Okay, now let's start our lecture. So I will first talk about some basics, and the related chapters are chapter 1, chapter 2, and chapter appendix. So first, let's talk about opportunity cost. What is the opportunity cost? It is basically the best alternative you have to give up to obtain something, right? So I guess this definition is not that clear to you, but let's go through several examples. And I hope these examples will give you a clear idea of what is the opportunity cost. First, think about your college education, right? What is the opportunity cost of your college education? Well, the opportunity cost of your college education is the wages you have to give up, right? Think about this. If you're not sitting here taking this class, if you just work full time, then you could earn more money, right? So because you're taking this class, because um, you're attending a college, then potentially you either have no wage or you have to work a part-time job, so your wage is lower. So the wage you give up for attending this college is the opportunity of attending this college, right? The second one, um, okay, the second one is not particularly interesting. Let's talk about the third one. Now you're sitting here watching this video, right? Of course, by watching this video, you're also paying your opportunity cost. Now remember that the opportunity is your best alternative you have to give up. So what is your opportunity cost? Well, you have to ask yourself. Think about this. If you're not watching this video, what is your best choice? What is the best action? What is the best activity you will engage? Right? For example, if you are not sitting before the desk watching this video, you could actually watch Netflix, right? Maybe that's your best choice, right? So in this case, not being able to watching Netflix is the opportunity of watching my video, right? Watching this video lecture. Now, the second concept is the uh, PPF, that is the production possibilities frontier. And you will see that why this is called PPF. It's basically a frontier. And this frontier talks about production possibilities. So the definition of PPF is it is a picture, it is a graph which shows you the combinations of output that the economy can produce given the available factors of production and the available production technology. Right? So the, the central message here is production possibilities frontier give you gives you a picture which tells you the potential, the combinations of output, right? Given resources. What resources are we talking about here? Well, factors of production and production technology. Right? Again, definitions are always very dry. So let's look at an example. So this is a production possibilities frontier for, let's say, for Canada. Let's assume Canada could only produce two kinds of things, right? The first one is computers. The second one is cars. Let's assume Canada could only produce cars. Now we're getting this production possibilities frontier here. That is this line, this darker blue line, right? This is your production possibilities frontier, right? And you can see that this production possibilities frontier basically separates this graph into two parts. The first part is this outer part, right? This is the outer part, right? This is the outer part. And we also have this lighter blue inner part, right? This inner part, right? So we have this outer part and inner part. And let's see what kind of information we can get from this picture. So first, the production possibilities frontier actually gives you an idea of opportunity cost. Why is this, right? Why? Now let's look at point A and B here, right? Let's look at point A and B. Okay, let's say we're looking at, point A and B. And you can see that, okay, to be more specific. Let's say we want to go from, let's say we want to move along this frontier. So we want to move from point A to point B. Now let's see what happens, right? Whenever you move from A to B, the quantity of cars increases from 600 to 700, right? So the following happens. Cars increases from 600 to 700. Now, what happens to computers, right? Computers. Well, the quantity of computers decreases, right? It decreases from 2,200 to 2,000, right? Now, let's ask the following question. What is the opportunity cost of producing this additional 100 cars, right? Remember that when the cars goes from 600 to 700, we have this additional 100, right? So what is the opportunity of this additional 100 cars? Well, you guessed it. Obviously, when you're from point A to B, as you get additional 100 cars, you have to give up 200 computers, right? So you can see that the opportunity cost of 100 cars is 200 computers, right? So this basically means the opportunity cost of one car is two computers, right? Okay, let me summarize. Production possibility frontier gives you the quantity, the numbers about opportunity cost. In this example, that is when we go from A to B, we can calculate the opportunity cost of 100 cars is 200 computers, which is equivalent to say the opportunity cost of one car is two computers, right? Okay, that's basically the first lesson we could obtain from the opportunity cost. Okay, let me put a number here. Let's say this is the first lesson. Let's think about the second lesson. Remember that in the first lesson, we have learned when you go from A to B, the opportunity cost of one car is just two computers. Now, let's observe a different point. Let me call this point as point G, right? Let's ask what happens when you go from point B to G, right? Okay, let's see what happens. So when you go from B to G, cars, the number of cars goes from 700 to 1,000, right? What about computers? Well, computers, the number of computers decreases from 2,000 to what? To 0, right? Well, because we're looking at this point G here, and you can see that at this point you have 1,000 cars, but 0 computers. Now, what is the opportunity cost um, of 1,000 additional cars? Well, we know how to calculate this, right? So for this additional cars, you can see that we get 300 additional cars, and we have to give up 2,000 computers. So the opportunity cost of 300 cars is 2,000 computers. Or you could say it's one car. Okay, the writing here is pretty bad. So it's one car and 6.67 computer, right? Why do you get 6.67 here? Well, because 2,000 divided by 300 equals 2.3. Because 2,000 divided by 300 equals 6.67. Now, if you compare, right? If you compare um, this number and this number, what's your observation here? Well, your observation here is the opportunity cost of producing one car is not constant, right? So let me write down these numbers on this curve. So on this curve, the opportunity cost of one car is two computer. Let me use 2C to represent two computer. Now, can I change a different color? Oops. Okay, I'll stick to red color. This is really not good. Okay. So for this curve, it's two computers, right? Now for this part, it's 6.67 computer, right? So it basically tells you that if you're having more and more cars, the opportunity cost of producing more cars also increases, right? Again, let me summarize. The second lesson here is opportunity cost along this curved production possibility frontier is not constant. Again, you can see that this whole thing is curved, right? This frontier is curved. It's not a straight line. So the lesson is the opportunity cost along this curved frontier is not constant. And to be more specific, as you get more cars, the opportunity cost of getting more cars also increases, right? A side note is, okay, let me make this more explicit. So the second lesson I just talked about is opportunity cost along a curved frontier is not constant. But what about this? What about opportunity cost along a straight frontier? Let's say the frontier looks like this. Let's say this is cars, right? This is computer. Now the frontier is straight. In this case, if the frontier is straight, then the opportunity cost is constant. And very quickly, we will talk about the slope. After learning about the slope, you can actually understand why this is the case. But at the current stage, you could just memorize this. That is, if the frontier is a straight line, opportunity cost is constant. If it is curved, then opportunity cost is not constant. Okay, let's talk about the third lesson. Let me first remove these marks. Okay, let's talk about the third lesson. The third lesson is about looking at these points. Looking at these points. So you can see that we have different points on this graph. Let's say we have point C here, we have point F, and we have point D. What's the major differences between these three different points? Well, you can see it, right? Point C is outside of the frontier, and point F is on the frontier, and point D is inside the frontier. So what are these different locations of these points can tell us? Well, if a point is outside of a frontier, then it is actually infeasible, right? Well, because the frontier gives you the highest possible production you can get. So if the point is outside of the frontier, it means that even if you use all your resources, you cannot produce at point C. Now, what is point F? Well, it's on the frontier. So in this case, it is efficient. So why it is efficient? Well, it is efficient because here you're on the frontier and you're using all your resources to produce at this point F, right? The key here is you're using all your resources. That's why it is efficient. Now, what about point D? Of course, point D is obviously feasible because it's inside the frontier. However, it's inefficient, right? It is inefficient. Why? Why it is inefficient? Well, the reason is because I guess you could compare point D and point A, right? You can see that if you're producing at point D, you get 1,000 computers and 300 cars. But if you produce at point A, you get more cars and the same time, you get more computers. So you can see that point A is strictly better compared with point D. Why this is the case? Well, it is because at point D, you're inside this possibilities frontier. So you're not using all your resources to produce cars and computers. So this is inefficient, right? So basically, um, judging by the location of these points, you can see whether they're efficient, inefficient, or infeasible. Okay, that's for production possibilities frontier. And I can see that you have several additional slides. These slides basically covered all 3 points we just discussed about. So I will just skip these points. Oh, yeah, we have this additional slide about production possibility frontier. So here you can see that you basically have 2 frontiers, right? You have this blue frontier, and you have this, I don't know what they call it, it's this dark red frontier, right? Now, what you are observing here is a shift in the production possibility frontier. Basically, if you shift the blue frontier outward, then you will get this dark red frontier. Now, what you can see here is there are several lessons we can learn here. So what you can see here is if you compare point A and G here, right? These 2 points, A and G, you can see that G wasn't feasible. G was infeasible for production possibility curve blue, for this blue frontier, right? However, point G becomes feasible for the frontier for this dark red frontier. What's the conclusion here? Well, the conclusion is, well, basically, um, this dark blue frontier represents economic growth, right? Well, because hey, previously we could not produce at point G. Now we can produce um, at point G if we're staying on this dark red curve, the dark red frontier, right? So now we can produce at point G. It's because there was economic growth. Okay, now let's look at this example here. So here you have this straight line production possibilities frontier. And this production possibilities frontier is about producing computers and wheat, right? And we have these different points here. You can see basically the starting point is this. It's this table. Given this table, you should be able to draw out this production possibilities frontier. What you would need to do is actually pretty simple, right? You could see, okay, if wheat is 0, then the number of computers is 500. So you will write down, oh, sorry. So you will draw this point. And then if you look at point B, it says if computers, so if number of computers is 400, then the number of wheat is 1000. So you have this point. Continue to do this, you could actually draw out all these points, right? And after getting all these 5 points, you will connect them on this straight line. So it's a pretty simple process. Now let's see what kind of questions do we have here. The first one says, on the graph, find the point that represents 100 computers, 3,000 tons of wheat, labeled F. And the next question is whether it's possible for the economy to produce this combination of the two goods, why or why not? Okay, let's see. So we have to look for, so we're having two numbers here, right? We are having 100 computers and 3,000 tons of wheat. So we are having 100 computers. This is 100. 3,000 computers. Okay, this is F, right? So this is point F. The question is it possible for the economy to produce at point F? Of course it is possible, right? Because it is, again, inside the production possibilities frontier. So it is feasible. Now let's look at the next question, question B. It says, find the point that represents 300 computers and 3,500 tons of wheat, labeled G, and whether it's possible for the economy to produce at point G. Now, we have 300 and 3500. 300 is here. 3500, I guess it's here, right? So this is G. Now you can see that the economy, for this economy, it is not possible to produce at point G because it is outside of this frontier. It is infeasible, right? So again, let me emphasize, this is infeasible. This one is feasible, but it's inefficient. Okay, you can see that you have the answers here, right? So you can look at these answers yourself. Okay, the third concept we want to talk about is positive versus normative analysis. So first, let's talk about the definitions, right? What is a positive statement? A positive statement is a claim which tries to describe the world. So it is descriptive, right? The second type of statement is normative statement. It is a claim which tries to prescribe how the world should be. So it is prescriptive. The key word here is should. Generally, when a statement has the word should, then it is normative statement. Okay, let's look at the example. Which of these three, which of these statements are positive and which are normative? How can you tell the difference? Right? Let's look at this statement A. It says prices rise when the government increases the quantity of money. Right? So this is just a descriptive statement, right? It's as if you're talking about a fact. So this one is positive. Second says the government should print less money. So obviously you're making a judgment, right? You're prescribe a potential solution. And more importantly, you have this keyword should. So this tells you this is normative. Um, Statement C says a tax cut is needed to stimulate the economy. Again, you can see that you're making a judgment. You're prescribed something. Of course, here you don't have the word should, but the word is needed. Sort of has the same meaning as should, right? So here it is again normative. Now, statement D, an increase in the price of, so how do you read this? Burritos will cause an increase in the consumer demand for video rentals. So again, in this case, you can see that it is not, you're not making judgment. You're talking about fact, or you're talking about your research, or you're talking about your research result. So in this case, it is positive statement. Okay, the final section is about graphs. It's about pictures, right? I guess if you compare pictures versus text, right? Generally, you would prefer pictures. So that's why we need to learn about graphs, because graphs are really intuitive. Sometimes you have to maybe talk about 1 minute. However, if you use graph, if you show people the picture, well, people will understand it like in 2 seconds, right? So pictures are great. Okay, so let's first talk about three basic types of graphs. And these graphs are about graphing a single variable, right? A single quantity. So we have pie chart, we have bar chart, we have time series chart. The one on the left is a pie chart. And you can see why it is called a pie chart, right? Because it looks like a pie. And you can see that in this case, the pie chart tells you how U.S. national income in 2008 was derived from different sources. Pie chart is generally great uh, for graphing or for telling you something about percentages. Right? You can see that here. You have all these percentages, wages and salaries has a percentage of 70%. Now bar chart, right? It's bar chart because you could see that you have three bars here. And here the bar chart is about comparing the, I think it's about average, yes, it's about average income between Canada and Mexico and Nigeria, right? And then you also have this time series chart. So for this time series chart, for this horizontal line, you get time, right? That's why it is called time series chart. And then for this vertical axis, you could get different quantities. In this case, we're having this unemployment rate. Okay, now let's talk about pictures of two variables, of two quantities. This is our major focus in this course, right? We will look at a lot of two variable, two quantity pictures. Why do we care about this type of graph? Well, it's because as economists, we are often concerned with the relationship between two quantities, two variables, right? Such as price and quantity, right? This is the relationship between price and quantity is very important. So how do we um, think about, or how do we draw out these um, two variable relationships, right? Well, what we will do is we will use a two-dimensional graph, right? That is, we will have this x-axis and y-axis. This is obvious because if you have two quantities, then you can see that x-axis could represent one quantity and y-axis would represent the other quantity, right? So it's a great way to make it easy to see how these two quantities are related. Let's say this very simple example. Let's say you're trying to examine how student performance and study time are related. So what you would do is you could measure two things, right? You could measure GPA. Of course, this is a measure of student performance. And you could also measure study time, right? And then you could actually plot these different points on this two-dimensional graph, right? Say, for example, for this point basically says if this person spent 5 hours per week, then this person would get a GPA of 2. And then you could continue to do this experiment, right? You can see that you could have other points, such as if this person spends 25 hours, then his GPA would be 3.5, right? So you could get many more points in this way. And then you can see that these points basically tells you a very initial relationship. That is, as you put more time into your study, your GPA will be higher, right? So you can see that using graph, you could see this result in a very neat and very quick, right? Okay, next, let's talk about slope. So what is a slope? Mathematically, slope equals change in y divided by change in x. You have this sign here. This sign is called delta, right? So this is delta. And it means change, right? So delta y, right? Delta y means change in y. Or if you don't like delta, you could use words, right? Change in y divided by change in x. I guess most likely you have learned about this concept in middle school. Um, a very convenient way to memorize this formula is slope is or equals rise over run, right? So let's see what is a rise. So if you have this curve here, right? You have this x and y. And then you want to find out what is this slope of this line, right? What is this slope here? What you're gonna do is you could pick 2 points, right? You're picking these 2 points. And then you can look for rise and run here, right? Oops, remove this line. So this gives you rise, right? And this gives you run. And then you can see that run essentially equals change in y. Rise essentially equals change in x. So slope equals change in y divided by change in x. Equivalently, slope equals rise over run. And a basic concept is a straight line has the same slope everywhere. It's just a mathematical fact. And of course, you can prove it, but we're not talking about, um, but, but we're focusing on economics, so I will not prove this. And then the second one is a line with a larger slope is steeper, right? And similarly, a line with smaller slope is flatter. So let me give you some idea about this relationship. Okay, now let's say, again, we're thinking about x and y here. And we have these two lines. Which one is flatter? Well, you're right, this one is flatter. This one is, oh, it's not a sleeper, it's steeper. This one is steeper, right? Now think about this. Which one has a larger slope? Well, if you're familiar with these pictures, you would immediately see that the steeper one has a larger slope. But if you're not familiar with slope, you can do this. Again, you would use change in y divided by change in x, or rise over run, right? You can see that for these two lines, they have the same change in x. However, they have different change in y, right? This is the change in y for this steeper line. And this is the change in y for this flatter line, right? You can see that if you use this lower or this shorter delta y divided by delta x, you will get a smaller number. This basically tells you a flatter line has a lower, sorry, a flatter line has a smaller slope, right? Okay, now let's see an example here. So here we're having a demand curve. Of course, we have not formally talked about demand curve. However, our purpose here is just to look at this curve and calculate its slope. So let's just focus on this mathematical concept here. So our task here is to look for the slope of this curve, right? And let's say we want to make, we want to focus on 2 points, at this point and this point. And then we will use changing what, we will use change in y divided by change in x. Now let's say we go from, let me call this point A, call this point B. Let's say we go from A to B, right? Let's say we go from A to B, okay? Now, what is the change in y here? If you go from A to B, the initial value of y is 8. And the end value of y, that is the value of y at point B, is 6. Right? This is the change in y. What is change in x? So the initial value of x is 13. And the end value at point B for x is 21, right? So now you're having minus 2. Yes, minus 2 divided by 8, which is minus 1 over 4 or minus 0.25, right? Okay, that's for chapter 1 and 2. And you can see that if you compare this lecture note with your textbook, you can see that textbook has more contents and more concepts. So, well, if you have time, of course you could read the textbook. But the requirement is, if anything, which is in the textbook, but it is not in the lecture note, then it is not required. Okay, okay, let's do some exercise. Let's work on some true-false problems. Okay, I have to first download. Okay, the download is actually quite fast. So let's work on some true-false problems together. I have to tell you that the exam possibly will not have true-false problems. However, in the class, we will look at these true-false problems because I think they're simple and they're easy, and we could quickly finish all these problems. So they could serve as good exercises. Okay, let's look at the first one. The first one says a production possibilities frontier is a graph that shows the various combinations of outputs the economy can possibly produce given its factors of production and technology. Well, this is like the exact definition from our lecture note, right? So this one is correct. Okay, the second one. A economy can produce at any point on or outside the production possibilities frontier, but it cannot produce at points inside the frontier. If you recall what we have talked about in this class about production possibilities frontier, you can see that this is not right. The reason is because a economy can produce on the frontier or inside the frontier, but it cannot produce outside the frontier, right? So this is not right. Third, an economy is being efficient if it is impossible to produce more of one good without producing less of another. Well, this is correct. I know I have not said the exact words as problem 3, but if you think about it, right? What is this efficient? What is the definition of efficiency in the case of production possibilities frontier? If you look at this point A here, right? A is on the frontier. It is efficient. And you can see that if you're standing at A, and if you wanted to stay efficient, let's say you would move from A to D. In this case, you can see that you have more dishwashers. However, you have to produce less of what is this? Dog houses, right? Again, if you go from A to this direction, let's call this as G. If you go from A to G, you will have more dog houses, but you have to reduce the production of dishwashers, right? So this is exactly the same as the statement here. It is impossible for you to produce more of one good without producing less of another, right? Okay, let's look at the next one. Refer to the above figure 2-11. Points A, B, D represent feasible or attainable outcomes for society. The answer, the answer is yes, this statement is correct. Again, A, B, D, they're all feasible. But C is not feasible, right? Now, what's the difference between A, B, D, right? What's the difference here? Well, the difference the difference is A and C, they're feasible and they're efficient. Now, what about B? Well, B is also feasible, but it is inefficient, right? Okay, that's for the true false exercise. You can see that for each true false problems, you have these answers, and you will have these. You will have the lecture note, and you will have true false practices. uploaded to Nexus so you can look at these answers and think about the problems yourself. Okay, let's move on to the next chapter. So next chapter I'm gonna talk about is chapter 4. So I will temporarily skip chapter 3 because chapter 3 is more about international trade, and we will talk about it in the future. So now we start this supply and demand section. So this section is very important. It's the basic foundation of understanding, I would say, most areas of economics, right? So I hope you could um, pay your attention to this chapter. And then in the future, I mean, if you learn this chapter really well, it will be easier for you to proceed to other more advanced chapters. So, as I said, the chapter is about the basics of supply and demand. We have basically 4 major topics. We will talk about market and the competition, and then we will talk about demand, and then we talk about supply, and then we will combine demand and supply and talk about these 2 things together. Okay, first, let's start with market and competition. So let's first start with some interesting observations or facts. So when cold weather hits Florida, right, the price of orange juice rises in supermarkets throughout the US and Canada. You can imagine that this could be true um, because uh, because most orange juices they actually come from this Florida. Right? The second is about warm weather. Right? When the weather turns warm in Canada every summer, the price of hotel rooms in Caribbean and Hawaii decreases. Third, when a war breaks out in the Middle East, the price of gasoline in Canada rises and the price of used car falls. So the common thread of these events is about the working of supply and demand. That is, um, the observation of the price fluctuation of orange juice, right? And the changes in the price of hotel rooms and the changes in the price of gas, the they all come from the forces of supply and demand. So our task is to understand supply and demand and understand how the forces of supply and demand would actually affect prices. And after learning this chapter, you will understand why do we have these 3 interesting observations. So we first start from the definition of competitive market. In this introductory microeconomics course, at least in when we are talking about supply and demand, we will restrict ourselves to competitive market. This is really because competitive market is the very basic and simple form of market structure. So using competitive market as a starting point, it's easier for you guys. And at the same time, you could also get the main gists of supply and demand. So first, let's define competitive market, right? What is a competitive market? Competitive market is also called, um, at least now, we also call it perfectly competitive market. Um, in a nutshell, a perfect competitive market is a market with a lot of buyers and sellers. And because you have a lot of buyers and sellers in the market, then each buyer and each seller, they have very little impact on the market price. In economic term, this basically means buyers and sellers, they are price takers. They cannot set price, right? Sorry, the more accurate way to say this is they cannot affect price. You just take price as given. To be more specific, there are two requirements for perfectly competitive market. The first is we want the products, the goods offered in the market are exactly the same. Second, we want there are a lot of buyers and sellers. And then you can see that these two requirements are actually important, right? You do want you do want products and goods to be the same in the market. If they're not the same, then you will have a different type of market structure. And in the future, you will actually learn about it. Now, the second one is about we want numerous buyers and sellers in the market. This is easy to understand because if you have numerous buyers and sellers, then no single buyer or seller will have any influence over market price, right? So that's why they could become price takers. Imagine the opposite. Imagine the extreme opposite. If you have only one seller or one buyer, specifically, let's assume there's only one seller in the market, then this will actually become a monopoly market. It's a monopoly, which means that this seller can have the freedom to set whatever price he wants, right? So you can see that the second assumption is also important. It is not very easy to find examples for perfectly competitive market because you can see that perfect competitive market assumes there are numerous buyers and sellers, and it also assumes all goods are exactly the same, right? It's hard to find a market which satisfies all these two requirements. However, there are some market which is almost competitive, right? You can see that we have this example here. It says the market for wheat and milk, right? The market is almost perfectly competitive. You can think about this, right? Let's say milk, right? Um, I think all milk, I mean, all kinds of milk, right? They're roughly the same. Of course, you have some variations such as 0% skim milk, 2%, 3.25%, right? And you could potentially have organic and non-organic ones. But other than these features, they're almost the same, right? And also you have a lot of milk producers, right? A lot of milk brands to choose from. Now let's see the other opposite. Let's think about car insurance at Manitoba. Do you think it's a competitive market? Well, it is not, right? It does not satisfy the second requirement because in Manitoba, well, we do have numerous buyers, right? However, we only have one seller, right? That is MPI. So the car insurance market at Manitoba is not a competitive market because it does not satisfy the second requirement. Uh, Quick quiz: what are the features of a competitive market? Well, um, first, products are the same. Right? Second, we have numerous sellers and buyers. And the implication of this assumption is all buyers and sellers are price takers, right? Okay, now let's talk about demand, right? Basically, in the market, you have two sides. So you have the demand side, you have the supply side. We will start from the demand side. Okay, let's first go through several concepts. The first one is quantity demanding. It's easy, right? It's just the quantity you want. That is the amount you're willing to and able to buy. Second, law of demand. Law of demand says other things equal, quantity demand decreases if price increases. Right? This is very natural, right? Um, if if beef becomes more expensive because of coronavirus, then generally you should buy less, right? At least that's what happened to me. If restaurant meals become more expensive, then maybe you would just cook more at your home, right? Now, demand schedule. Demand schedule is a table that shows you the relationship between the price and quantity demanded. Now, demand curve. Demand curve is really a curve from demand schedule. Right? That is, it's a graph which um, gives us the relationship between the price of a good and the quantity demanded. Now, you can see that the demand curve is different from quantity demanded, right? Quantity demanded is a quantity. It is a number. Demand curve is a curve. It is a picture. This is obvious, right? However, there could be some confusions because demand, this guy, right? Demand is actually a short name for demand curve. So you have to remember that demand is not equivalent to quantity demanded. Again, demand refers to the curve, and quantity demanded refers to the quantity. It is a number, right? Okay, now let's talk about this demand schedule and demand curve. Then we could end this class. So this is about Catherine's demand schedule and her demand curve. So this part is what? Yes, this part is demand schedule. Right? It is demand schedule. So you can see that according to the definition of demand schedule, it is a table which tells you the relationship between price and quantity, right? This is exactly what you're getting here. You're getting the relationship between price of ice cream cone versus quantity of ice cream cones demanded. Right? So if you look at these numbers, it basically says um, if the price is 0, Catherine would want to eat 12 cones. If price is 2, she would eat 4. Right? Now, going from demand schedule to the demand curve is easy. What you can do here is you just plot these points, right? For example, if you look at the right-hand side, this is the demand curve, right? Oops. This is the demand curve. Now, you can see that the horizontal axis gives you quantity of ice cream cones, and the vertical axis gives you the price. You have to remember that by convention in economics, you generally want to put price on the vertical axis and quantity on the horizontal axis. So if you want to draw out this demand curve, you will just look at this demand schedule, right? It tells you if price is 2.5, right? If price is 2.5, demand is 2, so we get this point. If price is 2, then quantity is 4, so we get this point, right? You could follow the same steps and you can get all these points, right? Next, you would connect these points by a straight line. In this introductory course, we will always stick to this, not always, most of the time, we will stick to this straight line. Now, let's look at these two questions here. What is Catherine's demand? Well, Catherine's demand is given by this demand curve, right? So this is Catherine's demand, right? Next, what is Catherine's quantity demanded at price 2? Oh, we actually just talked about this, right? There are two ways to answer this question. You could look at the demand schedule. So at price 2 here, the quantity demanded is 4, right? And then if you look at this demand curve here, or look at this demand, you can see that so we're looking at this point, right? So if price is 2, you could see that quantity demanded is 4, right? So you can see that demand curve is a very convenient way to give you the information on this demand schedule. Okay, I think that's for today's class.